Good morning still. Yes, morning. Welcome to the technical forum here at Hydrogen Fuel Cells Europe at the Hannover Messe 2023. We still have quite some seats left here in the front. Welcome also to the online audience watching the live stream and all the future YouTube watchers. We will be talking about an interesting topic today. How are we going to go from digital twins to real power-to-X plant products and systems which is needed for a profitable hydrogen economy? On stage will be, I think, the biggest exhibitor of Hannover Messe. Not only do they have a booth here, but they also have literally half of Hall 9. So please welcome to the stage business developer at Siemens, Hubertus Boehm.
Well, thank you very much, and good morning, everyone. Thank you for having me. And I'm walking you quickly through a journey from digital twin to a real power-to-X plant. This is technology. And there's a couple of topics, 4 topics that I would like to cover. I jumped directly into Siemens's value position along the hydrogen value chain. So that's the picture we are using to show where Siemens is interested in and providing core components to certain industries. We have in the center the new shining star, the electrolyzer, which is the synonym for green hydrogen. But we see other new applications like airports here, which are requiring sustainable aviation fuels. This is based on methanol typically, so that's why I picked that topic. And all the other plants are basically chemical plants like that we know from the past. For sustainable aviation fuels and methanol, we need a lot of carbon, CO2. And believe it or not, I think this will be the scarce resource. So this is why you see in blue carbon capture and carbon storage as well. So what is our role in the hydrogen economy? So we are a provider of core components for electrification, automation, and digitalization. We have hydrogen-enabled portfolio. I will show you in a minute what we did to make some of our components ready for use in hydrogen applications. And we are typically dealing with 3 types of customers, which are the owner-operators of plants, so the ones that are running the plants, the ones that are building the plants, so I cover them today too, EPCs and general contractors, as well as all the package unit suppliers that you see here, including the electrolyzer, but also ammonia, methanol plants, and the like. I would like to point out there's a lot of confusion out there. We are getting many questions about performance of our electrolyzer. We are not making electrolyzers. So that's Siemens Energy. The confusion is, I'm not blaming anyone, but the Siemens is still in its name, but it's an own legal entity since 2022. Our former colleagues got promoted from colleague to customer, and it's much like Infineon and Osram. That used to be Siemens. Nobody knows that anymore, but that's the same thing with Siemens Energy. Again, if you would like to have an electrolyzer with the Siemens Energy brand, please contact Siemens Energy. I added some trivia here for the water consumption and power consumption for a 20 megawatt. That's the typical size of electrolyzers from Siemens Energy and others. And you see the water consumption is by 31,000 tons per year. And I would like to ask you the question, how many Olympic swimming pools are these? Any idea? It's an Olympic pool has 2,700 tons, so that's above roughly 12 Olympic pools a year. I'm saying this not to make a political statement, but I want to start a thought process when it comes to countries like Middle East, Africa, and the like. So everybody's only looking on the energy side. Water is also an issue. Let's jump in the digital twin. And we begin with the electrolyzer. There is the digital twin of the electrolyzer as the equipment. So that's now the product. And we are providing software tools like Technomatics, Team Center Technomatics, that allows you to build a factory, to design a factory around all the equipment that you need to put an electrolyzer together, or let's say a stack. Stack manufacturing is literally today manufacturing in most cases. We're just starting to increase the level of automation, and that would be the tools that help you greatly to design the product, the electrolyzer, the bipolar plates, and also how you assemble all the parts that you need. And this is the digital twin of your product electrolyzer. You can continue and optimize it in a way that you basically, there's precious materials in it, so basically you have platinum, iridium, and what you like to know is what is the minimum amount of material that you need to make the electrolyzer work or the stack, and you basically want to avoid that you put too much material in here. It's precious materials, it's expensive. So optimum efficiency with minimal electrode material consumption would be the goal. And the software that helps you simulating it is PSC G-Proms, which is a Siemens company that we acquired a couple of years ago. Now let's switch perspectives. We are going now to hydrogen production. So the product is no longer the electrolyzer. We want to produce hydrogen. So here is a hydrogen production site. And I'll cover a couple of topics in here. First, how do you want to build a plant? So you need a plant design tool that allows you to have all the P&ID, so that's the piping instrumentation diagrams, and you can combine it. It's object-oriented with 3D graphics in here, so you know exactly where it's located. And COMOS gives you all the packages that you need, including, so just not P&ID, it has the isometries, 3D engineering, pipe design, and also the electrical engineering. So it goes beyond process planning, because that stays with the entire life cycle. So that comes with you from feed, that's front-end engineering and design, up to modernization. And that's what I think about when I say life cycle. So you start with detail engineering, commissioning, operations, and the like. And in every of these phases, this tool has its role. So for example, if you do detail engineering, it is tightly integrated with our process control PCS7. It pre-fills basically all the engineering data into the process control system. It's tightly connected with Simit, a simulation tool that's coming next. And it even allows in the operation phase for scenarios like maintenance, repair, and overhaul. So it will give you all the instructions to what you need to do to change a pump, for example. You can interactively do that with the operator so that you make sure it's safe to perform that operation. So the operator may need to shut down a valve and the like. You need to make sure that it cools down. All that can be done. So it really stays throughout the life cycle. And with the 3D graphics in here, it even is an asset locator. So you find an equipment, so it's sometimes difficult, where is that pump? And that is very helpful for people coming on the plant site that are not familiar with it. Simit, that's the simulation tool that serves two purposes. It's virtually commissioning, so at times when you don't have the equipment at hand, you can pre-test your control strategies already. So this is giving you the process feedback to your control system that is missing because the real electrolyzer or plant is not there. It even replaces a hardware controller. We have virtual controllers where you can download engineering data, and you don't need to have the hardware on hand. But the second use is you can use it as an operator training system. So with all these process feedbacks that you have programmed, basically you have the entire functionality ready as a digital twin, and that you can train operators or people that are new in the company on how to start up and stop the electrolyzer. So for that particular, for the Simit software, we have a library for electrolyzers that has all the bells and whistles. So it gives you the it calculates, depending on the cell voltage and the current, on how much hydrogen is produced and how much oxygen. You can play with it. Here we have different scenarios like startup, shutdown, load changes, and the like. So now let's get to reality. So again, we start with the electrolyzer. So we want to have a power-to-X plant at the end. We start with the electrolyzer, and this one needs a lot of power. Yeah? So also this is available from us. We designed all the transformers and circuit breakers, the medium voltage and low voltage switchgear that you need, because we are talking about voltages about like 600 volt and 6,000 amp. So that's quite, you see, we designed the containers. We have the DC master product that is controlling the power. And so we did all this, and this is very space consuming. Usually the buildings that host these parts are larger than the electrolyzer building. But we also have other products for automation. So that was the electrification part for the electrolyzer. Here is the automation part. We are starting with the sensors. Here is where we have the portfolio that we modified. For example, pressure transmitters now come with gold plates, because hydrogen permeates through metals that are otherwise gas-proof, which would basically build back pressure on those membranes, and that would cause you ultimately bad readings or inaccurate readings. On the right side, also the European pipeline operators were very much concerned how accurate are flow meters when you have a mixture of hydrogen into the natural gas grid. So we had to pass a DNV test here, which we passed with flying colors. And the nice thing is this clamp-on flow meter can even be mounted at pipes that are on a later stage. You don't need to cut the pipeline, put a flange in, a reface plate, and all these things. So the beauty is really you attach it later to the pipeline. Nothing else needed in here. Next step would be the purification measurement. These are still products on the electrolyzer. We need to measure gas purity levels, because we heard a recent speech here on fuel cell performance, how easy it is to poison fuel cell membranes. But more important for the electrolyzer is the equipment health. So when there is a bad membrane, for example, then you would see oxygen on the hydrogen side. So we measure this with oxymat. And since this is an explosive mixture, this measurement is ATEX certified and SIL rated. Automation, we have two systems in place which we use at various customers, which would be the PCS7 control system or also thematic PLCs. The SCADA are being used. Here's a picture from a real-world application of an alkali electrolyzer in Grenzach. So it's all there. We deal with hydrogen for ages. Hydrogen is not new, just the way it's produced. So we have the SIL ratings, the ATEX zones, and everything in place. Now, coming to the end with hydrogen conversion to e-fuels, now we're adding a second automation layer on top of these package units, one of which is the electrolyzer. But carbon capture, methanol, and the gasoline synthesis are coming next. And what happens if you buy those 4 package units as an owner-operator? You may get a diverse automation landscape in here with a lot of issues coming with it. So that starts with different look and feel already. You have to learn 4 systems and the like. So make sure that you are getting this from a single supplier, and then all these disadvantages turn into advantages. And I also invite you, another way of integrating package units is MTP. That's a standard already mature. We talk about a lot in Hall 9, but it's a standard that makes it as easy to integrate package unit as it is to basically integrate a printer into on a personal computer. Proof of concept, here is a reference site where we did exactly this, and we did all the engineering, and you can see where the package unit suppliers are. They are listed in here, and that plant That's Svenja Schulze delivering an opening speech. And with that, I would like to say thank you. If you're interested, I'm open for questions here for a little while, and thank you for joining.
Thank you. Warm applause, please, for Hubertus Boehm. And you can continue this conversation with him at booth B22, which is roughly